Hi, everybody. My name is Vanina Costa from the University San Pablo CEU, and I'm here to introduce you to the article Design of a Robotic Platform for Hip Fracture Rehabilitation in Elderly People, accepted for the International Conference BIOROB 2012. In this project have collaborated the company Werim Assistive Solutions, the Spanish National Research Council, and Albertia Servicios Sociosanitarios Nursing Home. The motivation for this work arises from the study of faults in older people, which frequently end up with hip fractures, and the need to provide new solutions in this field of rehabilitation. Moreover, we are talking about an injury which has severe implications on functional dependence, social and economic costs, and even mortality in an increasingly population aging. This last event, especially during the first years following the fracture, is a consequence of not recovering people's previous functional activity, which therefore leads to a notable reduction in autonomous mobility. Robotic rehabilitation presents advantages compared to the conventional therapy, integrated functional tasks. These devices propose a cost-effective method and are more effective than the conventional one in reaching the patient's ability to recover walking independence. However, there is a lack of robotic devices for hip fracture rehabilitation. This work is about a new platform developed for this purpose, Swalkers. The main functional goal for the platform is to facilitate the early mobilization and ambulation using a safety walker frame. I will describe its conceptual design, technical development, and its functional validation. The platform build is based on the robotic device CP Walker developed at the Spanish National Research Council. In relation to its structural design, Swalkers is made up of 6 main modules, as you can see in the schematic picture. Let's look at each of these parts in more detail. First of all, the drive system with 2 motors and control encoders allows the robot to be pulled in all directions, driving the patient's gait. The user's body weight support system consists of a hydraulic pump and 2 vertically positioned pistons that allow the patient to be lifted and therefore the robot to support part of this weight, controlled by a load cell, allowing a comfortable and safe walk in the first stages of rehabilitation, when even the muscles of the lower limbs are not strong enough. The patient is held by the trunk and legs by means of a harness anchored to a rigid but adjustable structure surrounding the pelvis. To the left and right of this structure are integrated 2 potentiometers that measure the hip joint range while walking. 2 parallel bars, adjustable in height and stand on both sides, allow the patient to be held at any time, promoting safety. The transfer of an elderly patient to this platform can be complex, so the front TS structure can be completely removed and the robot is left on a small support, as you can see. Finally, all the electronic elements are controlled from a PC0104 system located in the metallic box, which receives the signal from the sensors such as the potentiometer, load cell, or encoders. The electronic system communicates with a router via UDP, which in turn sends the communication via Wi-Fi to a software application on a tablet. With this application, the physiotherapist can control the robot during rehabilitation. Firstly, by entering the patient's data, the percentage of weight discharged, selecting the therapy, here they have 2 different walking modes, and displaying the results after the session. About the walking modes, in the guided one, it is the physiotherapist who starts or stops the robot. In the free walking mode, however, the robot's traction is activated by the patient's intention to walk. This is achieved when the patient exceeds a certain joint range at a given speed. The stop of the robot is also activated by the patient by simply placing their legs completely parallel in the standing position. Swalkers functional validation aims to assess several technical and usability aspects to ensure the robotic platform fulfilled the conceptual design. 5 healthy elderly patients and 2 physiotherapists participated in these studies. Healthy users have not used robotic devices previously, and they did not present intellectual disability. The tests were carried out in the facilities of Albertia Servicios Sociosanitarios. The session consisted of 30 minutes walking along 25 meters corridor. Before starting the functional test, a guide of use was elaborated. This guide prepared technicians and clinicians for the correct handling of the robotic platform. Its main points were general description of the Swalkers, precautions and checks for safety, recommendations for the transfer procedure, and configuration of the therapy. During the tests with these subjects, technical and usability aspects that will serve to create a future prototype were evaluated as approved or to be improved. Scanning all aspects were approved, and those that could be improved were collected and analyzed in greater depth. Additionally, the 2 physiotherapists in charge of conducting the sessions answered a usability questionnaire based on the system usability scale. This questionnaire evaluates 10 different usability aspects, such as if they feel very confident using the system, or if they think that they would like to use this system frequently. Each aspect is scored differently depending on whether it is better or worse for the system. Finally, a score is obtained that will be between 0 and 100, being 100 the best. In this case, as you can see, very good results were obtained. As conclusions, we can say that this project aimed to present an innovative approach, applying a new robotic device, Swalkers, for the rehabilitation of hip fracture in elderly population. The system integrates mechanical and electronic modules that enable the physiotherapists to control and implement personalized rehabilitation. The technical and functional validation consisted of identifying, evaluating the key functions and characteristics of the system. All the verification points resulted validated. Additionally, the physiotherapist fulfilled the system usability scale with positive results. As future work, the technical and the functional evaluation of the Swalkers prototype will be useful to develop a more robust second prototype. Finally, this second prototype will be clinically validated, measuring the impact on the rehabilitation process after hip fracture. Thank you very much for your attention. I would like to take this opportunity to thank the BIOROB International Conference and all its sponsors for giving us the opportunity to be part of it and present this work.